Hello, this video is an introduction to linearization of functions, and this is coming from section 3.10 of the textbook. And so the question will be, what is a linearization and how do you apply one? So let's go back and review the basic concepts that we have. Calculus is the study of functions or curves, and then we were going to think about a function at a particular point has a tangent line, and we have seen that the formula for the tangent line is we'll have slope equal to the derivative evaluated at the point, and we were going to use the point slope form, and we're using the point x0, y0, and the y0 of course is the value of the function when we x is equal to the specific value of x0. The linearization of the function at x0 is nothing more than the tangent line. So I want to write this like here so we can compare the equation for the tangent line is exactly the same as the equation for the linearization. Okay, and the important thing about the linearization, and just like the tangent line, if x is a value that's close to x0, then the value of the function evaluated at x is approximately the value of the linearization, right? So this is saying if we have somewhere we have a given x0 and then we have an x that's close by, there's not too much difference between the value of the function on the value of the function and the value of the y-coordinate on the tangent line. Okay, so we're going to find the linearization of a given function at a equals 1 and use it to estimate the square root of 3.98. And the function is the square root of x plus 3. In this example, even though it says a is equal to 1, we're thinking of that as the x value, so we're going to take that as x0. And then the y value is y0, that would be f evaluated at x0. We just plug in 1, which is our value there, and if we square root of 1 plus 3 is the same as square root of 4 is 2. And now in order to find the linearization, means find this tangent line, we need to find the slope of the function using the derivative. So I'm going to write the function as x plus 3 to the power of 1/2. And when we do that, f of x, the derivative, will be 1/2 times x plus 3 to the power of negative 1/2. Of course, we might have to think about, oh, there's an inside, the derivative of x plus 3, oh, that's just 1. So technically speaking, we would need the chain rule there. But 1/2, 1 over square root of x plus 3, if we rewrite that using the correspondence between negative exponent, tells us we have a reciprocal, the fractional exponent 1/2 says we have a square root. Okay, so when we do that, when we plug in f prime of x0 to give us our slope of our linearization or slope of our tangent line, we get f prime of 1, which is 1 over 2 times the square root of 1 plus 3. I'm just using that formula right there. And of course that's 1 over 2 times 2, so it's 1 over 4. Okay, so we have all the ingredients that we need. We're just going to write the linearization is the slope, which is 1/4, times x minus x0, which is x minus 1, plus y0, which is 2. Now we want to go on and use this linearization to estimate square root of 3.98. And of course we're thinking of that as we're going to put in some x value and into our function square root of x plus 3 and get out square root of 3.98. So 3.98, that means that's equal to x plus 3. Oh, so we should be using x is equal to 0.98. In that case, the square root of 3.98 is f of 0.98, right? And then this would be approximately equal to the linearization of 0.98, and that's because 0.98 is close to 1. Okay, and so we plug 0.98 into our linearization, and there we have it over there. 1/4, x is 0.98 minus 1 plus 2. So we got it going on there, and then we get negative 0.02. That's the difference between it's the difference 0.98 minus 1 over 4 because we're multiplying by 1/4, plus 2. That would be negative 0.005 plus 2, and of course that would be 1.995. And if we were to look at things in the calculator, we'd see this is really close. The calculator says 1.99499, and there's more digits, but this is really, really close. That's all for now.